Hello, today we are starting our section 4.4. It's about properties of log. First property we are doing is product property of logarithmics. What does it states? It states log of products can be converted into sum of logs. That means if we have log of xy, product of two numbers with any base b, that would be equal to log of x with the same base b plus log of y with the same base b. So in simple, this is what product. So log of products is equal to sum of their logs. That is how you can remember this property. Now, if I have to prove this property, let's write it down one more time. I need to prove that this is equal to this. So let me start by assuming this, naming it something. Let's say this number is m. Let's say this number is n. So we have m is equal to log of x with base b. By definition, what does that mean? B should be raised to m to get x, right? Similarly, we are saying that log of y with base b is equal to what? N. What does that mean? That by definition means b should be raised to n to get y. Okay. So that means what we are saying is x is equal to b raised to power m and y is equal to b raised to power n. So x, y, the product of these two numbers would be b raised to power m times b raised to power n. Now we've already done exponential rules. If you remember, in exponential, we have a rule which states that if the base b is raised to power say m times b raised to power n, if the base is same and it's multiplied, the powers add, right? So that is your exponential rule. That means this can be written as the same base is there. That means the powers will add. Now we are saying xy is equal to b raised to power m plus n. This is an exponential equation. How can we write this exponential equation in log form? B is the base. So when we write it in the log form, the base would be b. B should be raised to m plus n to get xy, which should be equal to m plus n. Now what was m? M was log of x with base of b. So that is log of x with base b. N is log of y with base b. So we proved that log of xy is equal to log of x plus log of y. Product log of products is equal to sum of logs. Now let's see how we can use this in an example. Write logarithmic as sum and simplify if possible. Assume that x and y are positive real numbers. So it's given that log of 8x, the base is 2. Now if you see 8 times x, it's a product. So that can be converted into the sum of two logs. Log of 8, the base is 2, plus log of x, the base is 2. Now in this case, the first one here is log of 8 with base 2. I think we can solve that. The question is what should 2 be raised to get 8? That number is 3. So log of 8 with base 2 will be 3 plus log of x with base 2. We can't find that because we do not know x. This is your answer to the first part. Now, log property, this is the log property. This would apply to any log. So it will apply to log with base 10. That would be common log. It will apply to natural log also, right? So in the second part here, this question is natural log of 5xy. So the product property will also apply to natural log. So we will say natural log of 5. This is product of three numbers, 5 times x times y. So we will have natural log of 5 plus natural log of x plus natural log of y. Log of product converts to sum of the logs. We can't really simplify anything. At the max, you can find natural log of 5 from the calculator. So you have to check in the questions they are asking you to find it or just leave it at this. Next we have natural log of 3 times a plus b. So 3 is multiplied with a plus b. So natural log of 3 plus natural log of a plus b. Now here is a small note. Please remember, log of product is the rule. Log of sum is not rule. So we cannot really. So I had students sometimes they would write log of a plus log of b. That is wrong. Do not do that. Okay. This is to be written just log of natural log of a plus b. We cannot simplify any further. There is no rule which opens it up like that. So do not do that. This is your answer. After product property, next property of logs we are going to do is quotient property of logarithmics. So quotient property, what it does is converts the quotient into the difference of logs. So log of quotient is converted into the difference of logs. Okay, so what we are saying, if we have log of x by y, quotient of two numbers with any base, that can be written as log of x with the base same minus log of y with the same base. The base is staying same, you have to remember that. Okay, now this property can also be easily proved with the same method. Let's name this number m and name this number n. So we have m is equal to log of x with base b and n is equal to log of y with base b. This is a log form equation which can be converted into exponential easily. What does this statement means? That b should be raised to m to get x. Similarly, b should be raised to n to get y. So we have b raised to power m is equal to x, b raised to power n is equal to y. Now, what if we have to find x by y? That would be b raised to power m divided by b raised to power n. Now, we have rules of exponentials which states that if we are dividing two numbers in the exponents and the bases are same, then exponents get subtracted. That is the rule of exponents, right? So, x by y is equal to b raised to power m minus n. Now, this is an exponential equation, can be written back into the log form. How? We can say the base is what? The base is b. So, log of x by y with the base b is equal to what? The exponent m minus n. We did that a lot, many questions with this type, right? Now, what is m minus n? M is, that is where we started from. M is log of x with base b minus n is log of y with base b. So that proves our quotient rule. Log of x by y is equal to log of x minus log of y. So that is our property here. Quotient rule. What does it do? It converts log of quotients into difference of logarithmics of the numerator and the logarithmic of denominator. Let's see how we can use this in an example. The question number 2 is, write the logarithmic as the difference of logs and simplify if possible. The first part here is log of z by 49. The base is 7. Now that one would be written as, it's a quotient of z and 49. So log base 7 of z minus log base 7 of 49. Now this we can't really solve because we don't know z. But this one here, the second part, log of 49 with base 7, meaning what should 7 be raised to get 49? I think that number is 2. So this is your answer to the first part of the problem. Part B, it is common log. There is no base written, so common log. It's 100 by x plus y. So we can say log of 100 minus log of x plus y. Common log of 100. Common log means the base is not written, but I think if we not written, then we know that it is a base is 10. So what should 10 be raised to get 100? That number is 2 minus, remember, log of x plus y cannot be solved any further. This is it. Do not make that mistake. Don't write it as log of x plus log of y. That would be completely wrong. The last one here is log of a by 14. The base is 7. So the base stays the same. Log of a minus log of 14. The base stays 7. So this is how we can use the quotient property of logs. Next property we are doing is power property of logarithmics. If b and x are positive real numbers, b is not equal to 1 and p is any real number, then log of x raised to power p with the base b, the power comes up front. This power, we can say this will go up front. It will become p times log of x with the base b. So that is how I remember log of x raised to power p with any base. The power comes out of the log. It comes up in the front. P times log of x with the same base p. Let's see how we can use this to solve. In example number 3, part 1 is natural log of fifth root of x square. So we have natural log of fifth root basically means 1 by 5, right? Fifth root means power is 1 by 5. Now using power of power, this would become x raised to power 2 by 5. Now using power property, this 2 by 5 can come up front. So that would be written as 2 by 5 natural log of x. So that is your answer. Okay. So all the properties which apply on log with any base b will also apply on common log and natural log. Let's look at the second part. Log of x square. According to power property, 2 comes up front. So that would be written as 2 times, this is common log, log of x. That is your answer. The last one here is natural log of e raised to power 5. Using power property, this 5 comes in the front. That would look like 5 natural log of e. If you remember that natural log of e is 1, so 5 times 1 is equal to 5. Natural log of e is 1 because the log base e the same, right? If the base and argument is same, the answer is 1 for the log. So answer to this question would be 5.